Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at that first one. So we have simplified the following: x squared y minus 3 over x to the minus 4 y5, and that's all to the power of a half. Okay, so this is continuing on from the stuff we were doing in the last class, where we are using the rules of indices, and I've just copied them over from page 21. Okay, so it's that column there. And to do any of these, you literally run up and down this list of rules and you apply them as you see fit. So there's a couple of ways you could approach this one. You could use this rule here, second from the bottom. Any of them, maybe the last one, because it's a division, and you apply p to the top and you apply p to the bottom. Okay, and we did a couple of examples of them in the last class. Or you could resolve the inside first, which is the division, so it's quite like this one. Simplify that and then do the power of a half afterwards. Okay, so I think the last one I did in the last class was where we did the inside first. So I'm going to do another example of the inside first with this one. So to do that, we have x squared y minus 3 over x to the minus 4 y5. Okay, so I'm just going to do this one a little bit slowly and show you what I'm doing. So the first thing I'm going to do is x squared over x to the minus 4. Okay, just like any other algebra, I can't merge the x's and y's, so I'm looking at the x's first. And you can see from that second rule that it's telling you to subtract the powers. Okay, as long as the base number is the same, which is the a's, which it is in our case, you subtract the powers. So you have x to the power of 2 minus 4. Okay, I'll resolve that in a minute. And then let's look at the y's. We've y to the minus 3 over y to the 5. So we end up then y to the power of minus 3 minus 5. Okay, and then that will all be to the power of a half. So I'm trying to get down to a single xy term with what I'm doing. Okay, so let's resolve that then. That's equal to x to the power of 2 minus 4, so that becomes plus 4, so x to the power of 6, and then y to the power of minus 3 minus 5 is minus 8, and that's all to the power of a half. Okay, and you keep going with whatever rule you see next. So then this is definitely this one. Okay, I have a single, how do I know it's this one at this stage? Well, I have a single x term, I have a single y term. So that's as simplified as it can get inside. And so now I need to deal with the half. So this one here, so basically it's telling me to apply the half to each term inside the bracket. So therefore I have x to the power of 6 to the power of a half, and I'll have y to the minus 8 to the power of a half. Okay, and now it looks like this rule here, the third rule, so it's power to a power. Okay, and when you have that, it's telling you to multiply the powers. Okay, so 6 times a half is 3, minus 8 times a half is minus 4. Okay, and then we normally write them with positive indices, so I'm going to use this rule at the end, a to the minus p, where it comes under the line, so the reciprocal of it, so it'll become y to the power of 4. Okay, so just another example of the videos we were doing in the last class. Let's have a look at the second one. I have root a cubed. I'll just delete out all of the rules here because we're going to use them all again. I have root a cubed over 4 root a by 3 root a squared. Okay, so the first thing here is you get rid of the square root signs. In other words, you write them with indices because you kind of need them as base number to a power before you can manipulate them. Okay, so the square root a to the 3. Okay, let's play with that one. Square root a to the 3. Well, I'll do it here as part of the sum. The square root of a to the power of 3. I'm going to use, which one does it look like? It probably looks like this one, I would say. This one here. Okay, so like we were saying at the last class, there's a little 2 there. Sometimes we don't write it in. Most cases we don't write it in. So if you have x squared is equal to 16, and therefore you know that x is equal to root 16, well, the reason the square root is the opposite of squared is that there's a little 2 there. We just don't write it in. If I have x cubed is equal to 8, then to get x, I would do 3 root 8. Okay, so you can see you can flip very easily from square roots to powers all the time. Okay, so it's that's what I'm doing here, but I'm going to use that too. So you don't have to learn the rule off by heart. But you have to be able to map it from here across to here. Okay, so let's try that. That gives me a. My p is the one on the inside and p goes on top. My one on the inside is 3. So it's to the power of 3 over, and then 2 is the one on the bottom. It's 2 that we have on the outside. Okay, so a to the power of 3 over 2. So the square root ones take a little while to get used of. Then if we have 4 root a, that would be the same as this one here. So we could write him as a to the power of 1 over 4. Okay, you can see the q goes on the bottom. And the last one, we have 3 root a squared. So that's the same as the first one we used. So it's a to the power of p goes on top. That's the inside one over the outside one. Okay, so to do these first, I would have written my p's and q's around them. So in other words, I would have had a little p there. I would have a little q there, so that I could map it across to a to the power of p over q. Okay, and that's the easiest way to do them. Just make sure you use the rules of logs. Make sure you just have a copy of them beside you. Right, so let's fill them into our equation now in the right place. So root a cubed is on top, so that's a to the power of 3 over 2. And on the bottom, I have 4 root a, so that's a to the power of a quarter, multiplied by 3 root a squared, a to the power of 2/3. Okay, so the easiest one now to resolve is the bottom. Okay, so that multiplied sign, that's actually the same rule as this top one. Okay, how do I know it? Well, it's got 2 base numbers, base number to a power. So you see the 2 base numbers, I have 2 base numbers and then 2 powers. So it's telling you to resolve it, to simplify it, add the powers. Okay, so a to the power of 3 over 2, I'm not doing anything with you yet. A to the power, so I'm popping on my calculator and I'm doing a quarter plus 2/3. And I'm getting 11 over 12. Okay, and then it looks like rule 2, which is the dividing one. So in that case, it's telling you to subtract the powers. So it's 3 over 2 minus 11/12. Again, popping on my calculator, 3 over 2 minus 11 over 12. And I am getting 7 over 12. Or sorry, yeah, 7 over 12. Okay, and then that's your answer. Okay, could I write it with the square root? Yes, I could. There's no need, but I could. So again, Q is the bottom one, P is the top one. So it would be Q is on the outside and P is on the inside. So 12 root 8 to the power of 7, okay? But the one in box is the one in the box is perfectly fine to leave it as that. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.